So hello everyone, in this video we'll be solving the question number 486, which is predict the winner. The question is marked medium. It is very easy to understand as well. The constraints are also very small, and yeah, we will understand few examples and then form an approach. If there will be any optimization required, we will do that. Okay, so let's first understand the question, what is it about, and then we will move to the examples. Okay, so what we are given now, we are given an integer array nums. Okay, and two players are playing a game in this array, player 1 and player 2. Player 1 and player 2 takes turns, with player 1 starting first. This is the main thing, that player 1 is the guy starting first. Both the players start the game with a score of 0, and each turn player takes one of the numbers from either end of the array. Okay, so suppose this is an array 152. Player 1 starts. He can take from any end. He can pick an element from left side as well. He can pick an element from right side as well. Okay, so yeah, after picking, it reduces the size of the array by 1. Okay, so if he picks an element from either of the side, the remaining array or the possibilities for the other player reduces by 1 because one element is taken. Okay, and adds the chosen number to the score. If player 1 takes a particular number, that number is added to his score. The game ends when there are no more elements in the array. If all the elements of a particular array are used or are picked up, then the game is ended. Game is ended. Okay. Return true if player 1 can win the game. So our main motto is to check if player 1 can win the game or not. If the scores of both the players are equal, then player 1 is still the winner. Okay, if player 1 has more score than player 2, then he wins. If player 1 has a similar score to player 2, then also he will win. Okay. You may assume that the both players are playing optimally. This is the most important line, that both the players are playing optimally. What does it mean? That it means that both players pick both players pick the elements in a way that they increase the chances of winning. How do they win? That is by they maximize their score. Whatever is left, they try to gain the maximum advantage, and as a result, they can win. Both players pick numbers efficiently. That is to win the game with available turns and elements. Let's first understand this with an example. Suppose we have this, what you can say, array which says 1, 5 and 2. Player 1 has two possibilities. Either he can pick this one or he can pick this one, because a particular player can only pick from either edges, which is from the left edge or right edge. If he picks the left edge, his score will become 1. If he picks the right edge, his score will become 2. Okay, now it's player 2's turn. He has two options, either 5 or 2, either 1 or 5. What he will do is he will pick 5, because if he pick up 5, if he pick up 5, his score will become 5, and whatever, let's make his score 5. And if player 1 picks this, his score will become 1 plus 2, which is 3. And in this case, if player 1 picks this, 2 plus 1, 3. So as a result, player 2 will always be greater than player 1. So as a result, whatever the way player 1 will pick, the player 2 will optimally or effectively overdo him, and as a result player 2 will win. So in this case the answer will be false, because whether how much he tries, player 1 will never be able to win. Okay, now let's take one more example. Here it is, player 1 starts. Now what we want to do is we want to find if player 1 who is starting the game can win or not. How can he win? He can win by making score greater than or equal to player 2, and both the players are playing efficiently. Okay, so we will try to consider all the possibilities and check which possibilities yield the best result. What is the best result? The optimal result. Okay, in this case player 1 can have two options, either 1 or 7. He picks 1, so his score in this case is 1, and in this case it is 7. Okay, after picking up, these are the remaining options for him, for player 2. What you can consider is that after a particular element has been selected, the number of options reduced by 1. Okay, and it is the reality. Okay, so now what happens is, if player 1 picks his left edge, player 2 has two options, which is 5 and 7. Okay, if player 2 picks up 5, player 1 has two options, 233 and 7. Either ways, if player 2 picked up 7, the player 1 would have two options. So you can say that player 1 played cleverly by picking up the left option, which made player 2 to have only two options, 5 and 7. Whatever he will pick, player 1 will pick up the 233, and as a result he will get the maximum score. So this was the optimum play done by player 1, and whatever was left, like these three elements were left, player 2 could almost do was pick 5 and then pick 7 and pick 7 and then pick 5. So as a result, this was the optimal way, and as a result, player 1 had a better score than player 2, so he won. So in this case, by playing optimally, player 1 can win. So you might have found one thing is that whenever a player is having a chance of the remaining array, he has two options. Let's write it down. This is the, just a second. For the remaining array, he has two options, either left or what you can say, or right. Okay. After picking one more thing, what suppose player 1 opted 1 over here, and what he will try to do is, after his score is 1, the player 2 picks a score such that the player's one score is greater than player 2's score. Okay, and or we can consider that player 1's score minus player 2's score is greater than equal to 0. What we will try to maintain is that player's 1 score is greater than player's 2 score, which can be reframed to make sure that player's 1 score, the player 2's score when subtracted from player 1 score still yields answer greater than equal to 0. He chose 1 over here. Okay, now what he will think is that after the score the player 2 will obtain from this sub array, let's suppose that score be x and this is 1, so 1 minus x be greater than 0. Okay, now it's player 2's turn. Now what player 2 will think is that whatever whatever the options are left with him, he gains the maximum result. Suppose he chose 5 over here. Player 1 has two options. So what player 5 will think that, please, the score of player 1 be 5 after this move. After this move, the score of player 1 be y. So please, the score of player 1 after this move be y, and as a result 5 minus y be greater than 0, because if this number is smaller than y, player 2 will know, okay, now he is losing the game. So what he will try to do is, let's try to make this also greater than or equals to greater than 0, because he also wants to win, right? So what we are thinking is that whoever be the player, it doesn't matter. What thinks is his pick minus maximum of possible answer obtained from remaining array be maximized. Why? This pick is of the current turn. the one which is having a current turn. And the, now this is the answer for the next turn. If player 1 has picked a particular element, he will make sure that whatever whatever the player 2 picks whatever the player 2 picks from the remaining array is what you can say greater than 0, or you can say that this entire thing is maximized, because this will give the if I picked a particular element x, and after that some part is remaining. Now the guy after me who is having a turn, he will also find a particular number. Okay, and we want to make sure that our score is maximized, because we do not know what things could happen in future, or that we are at which position. Suppose now what is here is x is also 1 minus x, so he also wants that okay, this 5 minus 1 5 minus y be a greater result, as a result that x which is used over here is also maximized. So this this requirement for one player 1 to win is broken, and player 2 wins. So everyone wants that whatever he has picked minus the possible answer the next guy would get is maximized. That is, this difference is maximized. Okay, so let's do this. But how we will do this is, might have seen that after at each junction we have two possibilities: take left element or take the right element. If we take left element, then also we have two possibilities, that from the remaining subarray take the left element, or from the remaining subarray take the right element. So you can say that this is a reoccurring solution, and for a reoccurring solution we use recursions. So let's first implement a basic recursions, in which what we will do is we have two options, left or right. After that, if we choose left, then we will do left plus plus, or we will do right minus minus. Okay, and what we'll do is pick that element and call the same function, because now it is the turn of another guy, right? Now we will call a helper for L and R, because if there are L was at 0 and R was at 3. If we chose L equals to 0, now L will become 1, right will remain as it is. If we chose right, the left will remain as it is, and the right will be decremented. So at each junction we need two variables, and we need an array. Okay, but till when? Till when we will do is till no elements are remaining. It is L less than or equal to R. Or we can say that if L equals to R, we set up as base case, and then we break return. Okay, but now you will thinking, what should we return? We want this pick minus helper for the left possibility and the right possibility, and from that we want max score. So we can think that as a result we want an integer. Okay, so now let's move to the implementation part. Okay, so we want to create a helper function. Okay, and we do not know what things we will require. We just know that we will require a left integer, right integer, and vector, this array which we have provided, vector int, sorry. Okay, now we have said that if left equals to R, we need to return something that we will find later. Okay, now we can have two options, whether we can take left or we can take left right. Let's take left. What is our pick? We will pick this current element, left element, and we want to find the score of the next guy, and we will try that our pick minus the score of the next guy is greater than or equal to 0, or whatever it be. Now the next guy will have a L greater than what, this same R and the same integer array. If we take right, int take right equals to nums of r. Now what is the remaining? This is the remaining subarray. Now we can now operate on the remaining subarray. The left will remain as it is, and the right is decremented and nums. Okay, and we want to return the maximum score. What is the maximum score? Which is the maximum of take left and take right. Okay, and we will return it. Okay, now suppose let's take this condition. After the player 2 has picked 5, now player 1 is now left with only one option, which is of 2. So now left and right both are equal, so only 2 is left, and furthermore no array can be formed, so we'll just return simply 2, because after that the game will end and no further uh, like possibilities are left for another player. So his new or more additional score will be for the next player will be 0, so it will be 2 minus 0. So we will simply return nums of L. Okay, and we will call this function return helper 0 comma nums dot size minus 1 and nums. This is not 0 but rather r. Let's try this code. What happened? Okay, sorry, we are returning integer type. Let's first understand. Okay, return nums of L minus L plus 1 take left take right. Okay, what's the issue? True. Okay, is that greater than equal to 0? We need to check if the score obtained is greater than equal to 0. Let's try to submit it. Let's first understand the time complexity. Here it has two possibilities in the recursion. Two possibilities, which is either take left or take right. And from each possibility, it further creates two more possibilities. Those possibilities create two more possibilities. Okay, so as a result it will be O of 2 power n, 2 power n, which is an exponential, which is so bigger. We should try to optimize it. Okay, so since it is a recurring problem and we can see that at each point particular tree is created, we can consider of DP. We can implement DP using a top-down bottom approach as well and bottom-up approach as well. We will memoize this recursion, and also we will use the vector DP to store. Since two variables are changing, we will be using 2D DP, and we know that L's range can be from 0 to n minus 1. Similarly, the R's range can be from 0 to n minus 1. So we will initiate or declare and initiate a 2D vector, and for each what you can say dimension, we will make it of n size. Okay, so how to do that? Let's take int n equals to nums dot size. Okay, vector int. Why int? Because for each L and R we are storing the score. Okay, dp size n, and for the inner dp vector int size n and initiate it with -1, and we will pass this to add this as a parameter to the function. Okay, okay, now we need to pass that to each and every call, and we will need to add that here as well. Okay, so after base case we need to check. We will check that if this situation has occurred before. Okay, if dp of I and j not equals to -1, we should not initiate this with -1, because what will happen if this number is greater than, what you can say, this r peak. So what we'll do is, instead of -1 we'll put it integer mean. And just for the information, integer mean is a part of limits library. So if you are solving on HackerRank or from scratch, you need to import the limits library to use this integer mean. And we return this dp of I j. Okay, and we give it a value over here as well. Okay, so yep, I guess that's it. dp. Okay, it should be ln r. Here also it should be ln r. Okay, so let's submit this. So now its time complexity will be not 2 power n, but rather be O of n square, because just a quick hack, the number of variables which are changing in recursion is the n power. Like if there are 2 variables changing, so it will be n power 2. If suppose there were 3 variables changing, it would be n power 3 time complexity. Okay, so yes, there is one tabular method as well, but if you want to use the recursion, I use recursion, in which first I create the basic recursion call and just add the memoization. So yeah, its time complexity is of n square, and the space complexity is of n square and 1 of this stack, so it will be O of n cube. Most probably I'll just confirm it. Okay, so I hope you guys enjoyed it. How we are using this difference method, because we pick a particular number and then we select it. If our number guy who is next to us, whatever he picks, we try to make sure that whatever the difference is, we are maximizing it. If we take the left pick, this is one answer, and if we take the right pick, this is the answer. So the pick which gives us the maximum score, we will use that. And difference is because we are maximizing it, because we know that each the players are trying to win. If player 1 picks this, the player 2 will give his best to pick the next element optimally, so as a result he can win. So we want to maximize it, we want to maximize the difference, and as a result everything depends on our pick and on the next guy's pick as well. So what we do is, we pick ourselves, we pick our choice, and try to create that difference, what you can say, subject, so we can win. Okay, so if you guys have any doubt, to let me know. And yeah, if you have any feedback also, to let me know. Thank you.